Right now, this problem is asking us to find the volume of water in a bowl, in a hemispherical bowl that has a radius of 15 centimeters, when it contains a ball of radius 5 centimeters. So first, let's draw some pictures. So it'll be very easy for us to find the volume of water when we can just specify everything in terms of h. So instead of having our circle be centered at the origin, let's have the bottom be at the origin and the sides just go up like this. And if we were to extend the circle, it would look something like this. So let's let this be our bowl. Now, what would the equation for this be? Well, if the distance between the center and the edge is r, then we can have our equation be x squared plus y minus r squared equals r. So this is the equation of our circle. So now what we want to do is figure out how we're going to find the volume of water in the bowl. We're just going to ignore the ball for now. Okay, so we can imagine the volume as a sum of all the circles between this x-axis and the place where y equals h. So we can sum up all of these circles with diameters that I'm drawing right now. And if we sum all of those up, we should get the volume of water in this bowl if we filled it to a height of h. So to do that, first we need to figure out how to find the area of a circle. So we need pi r squared. So for the radius, we would need to find the distance between this arc and the y-axis. So to do that, we need to solve for x. So if we solve for x, we get x squared equals r squared minus y minus r squared. So x is just going to be the square root of that, r squared minus y minus r squared. Whoops. It's going to be y minus r squared. So to find the volume of this, what we have to do is we want to add up all of the circles starting from y equals 0 all the way to y equals h. So that is going to be pi times the integral from 0 to h of r squared. So r squared, r is x, so we want to square this. So that's just going to give us y squared minus, r squared minus y minus r squared with respect to y. So right now we need to solve this definite integral. So we can simplify what's inside. This is going to be r squared minus y squared minus 2yr plus r squared. And right now, we can cancel out these two r squareds. And when we do that, we can take the antiderivative relatively easily. So right now, this negative y squared, the antiderivative of that would be 1 over 3 y cubed. And the antiderivative of the second term is going to be 2 over 2ry squared. So this is just r times y squared. So this can be canceled out. So what we get here is the volume is equal to pi times ry squared minus y cubed over 3. And this, of course, is evaluated at h and 0. So when we do evaluate this, what we're going to get is pi times rh squared minus h cubed over 3. So now when we plug in 0 and we subtract that, it's just going to give us 0. So this is how much water would be inside of a bowl of radius r when water is filled to a height of h. But what this also can represent is the amount of water a ball is displacing when it is placed into some water at a depth of h. So we can use this to describe both the volume of water inside of a bowl and also the volume of water that a ball is displacing. So now that we know this, we can go on and take this and solve our problem. So if water is poured to a depth of h centimeters, so if this water doesn't completely cover the ball, then what we can do is find the volume, which is equal to the amount of water just in the bowl. So that's going to be pi times the radius of the bowl, which is 15 times h squared minus h cubed over 3. So this is just the water in the bowl minus how much water the ball displaces. So what this is going to be is pi times the radius of the ball, which is 5, times h squared minus h cubed over 3. So this is going to be the volume if the ball is not completely submerged. So you can imagine we have some water over here, some water, and the bowl, let's make that this brown color. And if we have a ball, let's make that red. So if the ball is not completely submerged, then the amount of water in here is the amount of water in the bowl. So let's write this as this. So if it's at this height h, then the amount of water is just the amount of water in this bowl, subtract the amount of water displaced by the ball. So now let's consider the second case where the ball is completely submerged. And in that case, the volume is going to be the volume of water in the bowl. So let's write this again. Subtract. Now this is going to just subtract the entire volume of the ball. So this is going to be pi times, so the radius is 5 times the height. So if the radius of the ball is 5 centimeters, then the height of the water displaced for the ball is just going to be 10 centimeters minus 10 cubed over 3. So this is going to give us the volume of water in the bowl when the ball is completely submerged. So I'm just going to draw this bowl over here again. It's going to be a little bigger this time, just to emphasize that the ball is submerged. We'll use the same color. So if this ball is submerged here, then the volume of water in the bowl is going to be, let's use blue this time for water. So this is the volume of water in the bowl. So this is the first term. And the second term is going to be the volume of water displaced by the ball. So that is the second term. And what we get is just the volume of water displaced by the bowl minus the volume of water displaced by the ball. And this is in fact just equal to the volume of the ball, so the volume of the sphere. So this is actually equal to 4 over thirds pi r cubed. So this is our final answer.